Hey team, welcome to the next episode of CS with Val. Today we are going to talk about binary search. But first, let's talk about linear search. What is linear search? Take a second, think about it, pause this video. Okay, so linear search is the method of searching that we have used so far in class. So this is if you have an array or an array list, you start at the beginning and you look at each element next the each element to the next element to the next element to the next element until you find what you're looking for. That is a linear search. You would have seen this in um, like when you try to find the minimum element in an array, that is a modification of a linear search. It could be trying to find the maximum element in an array or the times that we try to find the average. All of those are variations of a linear search. So let's go with just the simplest example of us trying to find something using linear search. So given an array with a million distinct elements, they're in a random order. On average, how many elements do you expect to look through when you're trying to search for an item? You can assume that you can exit early. Take a second. Okay, so let's see. Let's look at maybe we will go from the bottom up here. So let's look at E. E says that if the item is present, we only have to look at about 20 different items. So that would assume that most of the time, with a million items, we're going to find our item in the 20th spot. That seems pretty quick. I think we'd probably need to look through a lot more items than that. Okay, so that doesn't seem very tempting. Let's look at D. We'd have to look through about 1,000 given a million distinct elements. That doesn't seem right either because we would be assuming that it's going to show up in the first 1,000 of 1 million. Um, and I'm just not really buying that right now. Item C, if the item is present, this says we would have to look through all 1 million elements. And now that seems too big because we might find it before the very last element, and then we could stop early. So what this is assuming, if the item is present, we would be looking through all 1 million and we would find it in the very last spot. And that seems very unlikely, even more unlikely than any of the other things that we have tested so far, or assumed so far. So let's look at B. With B, we've got 500,000. So that means that it would be about half. So we would look through about half of the items and find it somewhere in the middle. That sounds pretty reasonable. I'm liking that idea. So let's look at the second column. If the item isn't present, we would have to look through all 1 million items to find that it's not present. And that sounds reasonable too. So B is the correct answer here. If the item was present, we'd have to look through about half of the items in order to find what we're looking for. That's on average. Of course, some of them are going to be fewer than 500,000 items looked at when we try to find something, and some are going to be more than 500,000, but on average, it's going to be about half of the items present. And then if it's not present, it's going to have to look through every single item. So you can see how as our array gets bigger, this linear search is getting less and less performant. So let's talk about this linear search. What are the downfalls? So, as I said, sometimes linear search isn't efficient enough, especially as you get data that's more than 1 million elements, or really more than, 100 elements is even a lot. So, imagine a program. Of course, the type of search that you use is very dependent on the type of problem that you have. So let's imagine our problem. Our program is you make very few changes to the array. So you create the array and it is the array and you're not like adding to it or changing it very often, but you do lots and lots of searches on that data. So that means that it could be worth it. It could be worth it to sort that data so searches can be faster. If it's sorted, then you can kind of guess where in the array like the item that you're looking for might be. And while it does cost some computation time to sort the data, if you aren't changing the array that often and you are searching a lot, spending that time sorting so you can search faster, is a really good trade-off. And as I mentioned before, if the data is sorted, we can direct our search toward helpful elements. And there are unhelpful elements, certainly, that are way bigger than what we're looking for, or way smaller than what we're looking for, and we can just ignore them if the data is sorted. And this brings us to the topic of the day, our daily superhero, the binary search. Come back to the next video and we'll talk about that.